Hey class, here we go. This is your review today. This is also your notes. Tonight you have homework, which is I think 5 problems. Your other homework is to look at these notes that we made. Tomorrow you have a test and a lot of these questions look alike. So here we go. Question 1. Analyze the pattern of squares in the trucks and think about what stays the same and what changes. Begin your investigation of the pattern by creating a table to represent the pattern. Fill in the blanks. So we have truck numbers 1, 2, and 3, which show trucks 1, 2, and 3. Let's see. We have process column and total squares in the truck. The process column says this: 3 times blank plus 2. Total, we don't know, so let's count. 1, 2, 3, 4, 5. So I know the total is 5, and we'll just keep this up. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 here, and there's 11 here. Looking at this, we can see the patterns going up by 3, because it's 5 plus 3 is 8, 8 plus 3 is 11. If we look at the process, we're multiplying everything by what number? Well, we're multiplying by 3. So 3 times what plus 2 equals 5. If I do 3 times 2, that's 6. 3 times 2 is 6 plus 2, that's 8. That doesn't work for this one, but it works for this one. How can I get this for 5? Well, if I multiply 3 by itself, 3 times 1 is 3, plus 2 gets me that 5. So I have 1, 2, and let's try out 3 here. 3 times 3 is 9, plus 2 is 11. I want you guys to notice these numbers, 1, 2, and 3, which I'm boxing in, they also represent the truck number. So whatever I have for a truck number gets multiplied by our constant of 3. Alright, let's go over to part 2. The pattern of trucks can be described as follows. Truck 1 has 1 row of 3. Truck 2 has 2 rows of 3 squares. This pattern continues where the number of rows with 3 squares equals the number of trucks. Also on top, each truck has 2 squares. Write an algebraic rule that you can use to find the number of squares of any truck. We're going to use the letter X and use the letter Y. X is for the truck number, Y is for the squares. So let's make a note. X equals truck number, and Y is going to be squares. Right here, this looks kind of weird, and I know it's kind of confusing when it says tiles. Normally, we would do this on AgileMind, but since we're not using our laptops right now, we'll just circle our possible answers. So we have 3, 2y, plus x, and 5. So we're going to figure out what to do with these numbers and symbols and put them into these boxes. So right now, let's make our algebraic rule. Or, I like using the word equation because we have our equal sign. So I'm going to have y, and y is the number of squares. Here's what I'm going to do. I'm going to look over back at number 1. So we have total number. This is our y right here. And this dude is our x. Or I should rather say the truck number is our x. So we can use this process to help us with number 2. So we have y equals 3 times blank. 3 times the truck number, which is x. So y equals 3x. So let's cross out the 3. Let's cross out the y. And cross out 3x plus 2. Because if you look right here, we're adding by 2 in our process. So plus 2. So our answer is y equals 3x plus 2. Let's write this a little bit cleaner right here in the middle. Y equals 3x plus 2. Alright? So let's go on to the next one. Make a statement about the truck pattern that are true. Select all that apply. Let's rewrite our algebraic rule here. We have y equals 3x plus 2. Let's see. The fifth truck in the pattern will have 20 squares. Let's test that out. So if I have 3 times 5, which is the truck number, plus 2, and instead of y, I replace it with 20. Let's see if this matches up. 3 times 5 is 15, plus 2 is 17. Can 20 equal 17? That's a no. So we cross out A. Let's look at B. Some ordered pairs that represent the relationship between the trucks numbers and the squares are truck number 1 has 5 squares, truck number 2 has 8 squares, and truck number 3 equals 11 squares. Now, if you guys notice, I read that a little bit differently. We have these things called coordinate pairs. I want you to remember that the first number, which is 1, represents the truck number. And the last number, which is 5, represents the square number. So I have truck 1. Does it have 5 squares? Yes. Truck 2, does it have 8 squares? Yes. Truck 3, does it have 11 squares? Yes. So this is an answer right here. With 15 squares, we cannot make any trucks above the 4th term in the pattern. With 15 squares. Let's go back to our algebraic rule. Y equals 3x plus 2. I want you guys to know this. This is something that you could do for your test tomorrow. Once you have your algebraic rule, they're going to give you certain numbers. If they give you like the number 15, put it back into your equation. So the number 15, I'm going to put 15 right here. And the number 4, I'm going to see if it tests out for this number. So it'll be 3. And look at this. Instead of x, I write down 3, 4. Now, it's not 34. It's actually 3 times 4 plus 2. So 3 times 4 is 12 plus 2 is 14. Does 15 not equal 14? That's true. So we cannot make this. So we circle C. Let's look at part D. To find the total squares, we can substitute 6 in for x to find the equation. That's true. If we wanted to find truck number 6, we plug it in. So we put in 3 times 6 plus 2, and that gets us the answer. And the ordered pair of 0 equals 2 is not an answer. Let's try that one more time. Let's plug it in. I'll zoom out. Y equals 3x plus 2. We're going to put in 3 times 0 plus 2 and y. So 3 times 0 is 0. And then I'm adding it by 2. Y equals 2. So that's not right because this is an answer. So I'll leave it right here real fast and pause it so you can copy it down. Alright, let's go on to the next question. Which equation tells you the value of the truck pattern that creates 26 squares? Remember, we're looking for 26 squares, so that means we're looking to replace the letter y. Because the squares are y, and it's also the total. So let's just rewrite our equation again, which is y equals 3x plus 2. Which one replaces y? Not A, not B. B replaces x. C it is. Just to double check why we can't pick D, it's because it doesn't replace y, and also we're missing a letter X. So it's wrong on like a bunch of reasons. Alright, let's look at this guy right here. If we had 100 squares, what is the largest truck number you could represent? So let's write down our equation. y equals 3x plus 2. And we're using 100 squares. That's our y. So we're replacing the letter y with 100. So we have 3x plus 2. Let's draw a line through our middle. The opposite of adding is subtracting, so we'll subtract by 2. So we've got 98, and we've got 3x. Next up, let's do the opposite of multiply, which is divide. And that's going to be 98 divided by 3. Right now, I'm going to pause it real fast. I want you guys to do this division problem. How many times does 3 go into 98? Welcome back. So let's check our answer. 3 goes into 9 3 times, because 3 times 3 is 9. 0, I bring down the 8. 3 goes into 8 2 times. 2 times 3 is 6. I'm going to get a remainder, a decimal or fraction. But if we look at our answers, all of them are whole numbers. So I'm going to ignore the decimal, and I see it matches with answer C. Alright, let's go on to the next one. I'll zoom out. A rectangular shaped pool has a perimeter of 128. And a length of 60. What is the width of the pool? Select the equations that represent this. Select all that apply. Most likely we'll have more than one answer. We have 128 feet, which is the perimeter, length of 60, width of W. So let's draw this swimming pool, which looks like this. So our width is W, and we have 60 and 60. To find perimeter, we could write it two ways. We could write it down 2 times the width plus length, or perimeter equals 2 plus what is this? 2 plus width plus 2 plus length. Here's what we're going to do. So let's plug in our stuff. So I should have a perimeter that equals 128. And then I have 2 times W plus 60. That's one way I could write this. So let's see if we can find that. It's not going to be A because 2 plus width, so that's wrong. It can't be B, 2 times width plus 2 times 60. That's not quite right there. But I do see something right below it in D. Another one that is correct is going to be C right here. So there we go. Alright, I'm going to move it up right here. We're on the next problem. This is the last problem I'm going to do. And then on the back, there's 3 more problems that I want you to do in class on your own. So here's this problem. And then in class, you've got to do these last 3. So we have Mary, and she has $50 to spend on t-shirts from an online store. There's $10 shipping and handling fee. And each shirt costs $5. Which inequality represents the number of shirts in S you can buy? So inequality means we're having these mouths here. The alligator mouths, the less than, greater than. Here we go. So we have $50. Okay? I'll write down 50. And there's a $10 shipping fee. So we don't know what the symbol is going to be. I'm just going to write down an equal sign right here. This isn't official yet, so I'll zoom out. So we have $50. And she's spending $10 on the fee, but then each shirt costs $5. So it's 5 times S. When she buys an amount, so when she's buying an amount, it can't, she has to be about equal to, or she's got to figure out how much bigger it is. So if we look at these right here, look, we have 5S plus 10 is less than or equal to 50. That's not quite right. This is way off, B, because there's a subtraction sign. C looks pretty good. D is wrong because it has subtract. And then look, the variable is on 10. And remember, she's spending 10 for shipping and handling. So the right answer has to be C. Alright guys, this ends the video. Me and Miss Flores are going to walk around to help you guys out with the last 3. But we expect you guys to do the last 3 on your own.